Hello everyone, welcome back. Okay, so the last bit of chapter 6 that we're going to talk about is wedges. Wedges. So wedges are tools that use the mechanical advantage of a small slope to lift a large force when we have a comparatively small force input. Sadly though, this means we have at least 2 separate free body diagrams. Ooh, no fun. And you have to figure out how all the forces are acting on these bodies. So for example, if I look at this one right here, I've got to have a free body diagram for everything together. And I can also break it apart and say, well, this is an equilibrium and this is an equilibrium. Both are in equilibrium. Also, for all these cases, motion will be impending. So I'll have to figure out what direction things are going to move. Like in this case, I'm going to have, okay, well, friction is going to be going the opposite direction there, because motion is going to be impending in that direction. I'll have a normal force here, and this guy, he's going to be moving up, so I'll have friction pressing down on him, and normal force here. So that's one free body diagram, but it won't be enough to solve, at least not normally. So I have to break it apart. So I look at this one and say, okay, well, there's going to be a second frictional force from the block on top, as well as a normal force pushing down. So that's one free body diagram. Or I'll be looking at just a block and saying, okay, well, it's going to be resisting me. I have to go in the opposite direction now, pressing up. And I have to keep on calculating it. One by one, you'll get there. Be very careful with your directions for friction, just because it's reversed when you go from one free body diagram to another free body diagram when they share the same force. Like this friction force is the same as the one I had on the wedge. It's just the block is going to feel the opposite effect. Now we'll go through examples of this. You'll get to see me do it a couple times, so hopefully that'll be enough to show you how these steps work. But I wanted to go ahead and show that to you now. And of course, I always do this. Here's actually the free body diagram written out a little bit more nicely. And what you can see right here is the reversal I talked about. The frictional force 2 and the normal force 2, that shows up in both locations, but they're always reversed. I tend to get confused with this, and I sometimes switch it around directions. Yes, even your teacher gets confused with these things. So typically what I do is I focus on the wedge, and I say, how does friction move for the wedge? And then with everything that's touching the wedge, I just reverse it. I know how this one's going to move, so I know how friction is going to be resisting it on both sides. And then I can just reverse the direction for everything else. Okay, so I think that's it for this time. So thank you for listening. Be on the lookout for those example videos. I'll get them to you as soon as I can. And we'll go through a bunch of examples of how to calculate friction and how to solve problems with wedges. Just the one big thing I want to remind you today is friction is always in the opposite direction of motion, and that friction is either equal to the applied load if it is a less than our max frictional force, or friction will be equal to that equation if we're at our max frictional force. Okay, have a great day. Bye-bye.